working on filing the piston rings for the LS. The rings we will be using our Total Seal Advanced Profiling Steel rings. These rings are not moly coated. They are file to fit rings. So for the size, the ring gap we'll be running will be a 5.5 thousandths per inch of bore. So the bore size is 4 inches 30 thousandths. So that gives us a ring gap of 22 thousandths. So that will be the size of the top ring. So now we can go ahead and gap the rings. So I got the first top ring done as an example, so I can show you how I do it. So first, the chamfer goes up. It's hard to see it, but chamfer's up, and I marked the side that I'm filing, so I don't mix it up. And when you file the ring, you have to make sure that the edges are flat. So when you push them together, there's no gap on the top side or the bottom side. So with this one, it's 22 thousandths. So let me get the file or the 22 thousandths. When you put the feeler gauge in, it should drag just a little bit. This is the grinder or the file tool that I'm using. It's pretty easy. You just gotta put it like this on the tool, make sure it's flat. And what I like to do is I like to get a Sharpie and put some ink on the face that I'm actually grinding off, so I can see if it's uneven on the when I'm filing the ring. So you can see when you put it together, there's no gap. It's perfectly flat on both sides. Alright, we got our top rings gapped to 22 thousandths. So now let's gap the bottom or the second rings. So the second rings are a Napier style ring. They have this little hook, and it scrapes oil down from the cylinder into the oil rings. It's hard to see it, but these have to be facing down, or else it will scrape oil into the combustion chamber and it'll smoke. So you don't want that. So we will be gapping the second rings to 22 thousandths as well. Okay, now we're on the selection of the rod bearings, and what I'm having to do is combine two sets of rod bearings. One set is 1/1000 under, and the other set is standard. So with the standard set, I was getting clearances that were going to be in the range of about 3 thousandths, which is a little bit too large for this application, for this size. So what I opted to do is use a half a shell of a 1 thou and a standard size. So that'll yield me a 2.5 thousandths ish rod bearing clearance.
So 1 and 2 are complete. Now I'm in the process of torquing down number 3. I believe that's the one. Yeah, number 3. And then we'll measure that side, and then we'll see what it is. It's just the torque spec for this rod ball L19 is 80 foot-pounds. So that one's done. So that's over here. So now we'll go ahead and sweep it with the dot bore gauge. Let's see, what's it this one here? So number 3. So this should be roughly 2.5 thou. Yeah, it's about right. It's more like 26. So looks like we have all of our rod data in, recorded I should say. And I'm going to revisit this one because that one seems to be the outlier. And we'll see what we can, let's see if I can put another half in there to get it closer to the other ones. So number 3 pin is 2.0992, so it's 2/10,000ths larger than the rest. So that means, and all these measurements, clearances are predicated on this initial pin measurement. So this clearance here is actually not 21/10,000ths, it's actually 19/10,000ths. So we can go up another half thou on this particular rod. So I'm gonna go do that now. We are going to use this ARP rod bolt stretch gauge, and this is much more accurate than the torque wrench because the frictional forces between the threads and the heads of the bolts they vary. So you might put 80 foot-pounds on one bolt, but if the friction is a little bit higher on that set, then you're going to get less stretch because it's gonna reach that torque, that number quicker.
How do you know what it should be stretched to?
Manufacturer.
Oh, okay.
Yeah. So for these particular bolts, I believe it's 7/1000ths of an inch. So you basically put this on, and then you use a boxing wrench and you torque it 8 foot-pounds, which is it's gonna be a little bit of pain to do that. Mm-hmm. But that's how you, that's an accurate way to make sure
that it's right.
It's right. Yeah. No question about it. Right? It doesn't matter what lube you put on it, whatever. So that's what we're gonna be using once we get everything out, get them all in. So basically, if you were to take a rod bolt over here, what's number 4? Is this number 4? Yeah, number 4. So I'm gonna take this cap off with these bolt. So basically, if your rod was connected to this is how it's supposed to go. You're supposed to push it in like this, and if it was, you set this you could do it both ways, 2 ways. You can put it at 0 and measure it at 7, and then when the bolt stretches out, it gets longer, and then this needle is going to move to 7.
So you put that on the rod then?
On the rod. That's why you have to use a boxing wrench.
Oh, okay.
And then you measure that, and that ensures that the bolt is in its elastic range. Mm. Torque specs. Yeah, torque specs are 75% of a bolt's yield strength. The yield strength is at the point in which the bolt actually be plastically deformed. Yeah. Yes, it won't return. Yeah. The tensile strength is the point at which the bolt will actually break. Mm. So the yield strength, and you want to be, most manufacturers recommend that the torque spec be 75% of the yield strength. So you have 25% of margin. Let's say you over rev it on the bottle, hit like 11,000. Mm. Well, if let's say you stretch your bolt to 100% or like 99% of yield strength, then if you over rev it, then your bolt will plastically deform, and your bolt is no good.
Yeah.
If you and it basically won't ever return. So then your torque load is less. So because it's plastically deformed, your clamping load is less than it was before you over revved it.
Mm-hmm.
Or let's say you only stretch it to like 4,000ths. Well, now the bolt is really not in its elastic range, so it's easier for it to come loose. It can vibrate loose.
I see. Yeah.
Yeah, so you want to have...
Because the tension isn't as strong.
Yes, yep. Or actually, here's a better analogy or a better explanation. Let's say it's only at 4,000 stretch, and I don't know how much this is going to be on video, but you over rev it or you rev it like 7,000 and the bolt begins to cycle because it's at the lower range. So now the bolt is stretching. Now the external forces of the engine are putting loads on the bolts and they're just flexing back and forth and they'll fatigue and break. Versus if you get into
like the vibration just...
Well, not the vibration, but the stretching. So let's say you rev the engine up and when the rod tries to pull away from the cap, you're only at 4,000. So well, that external force will stretch it another 2,000ths, right? So the bolt's constantly being cycled and it'll break. It'll break, right?
Yeah.
Whereas if you clamp it down to 7,000ths stretch, the external forces of the engine are not going to come anywhere near that range. So the bolt won't ever get cycled. It'll just stay basically in its original state, and then you won't fatigue the bolt. Because you can't cycle. It's like bending metal like this. If you keep bending, it's going to break.
Yeah.
So same thing with this. If you do that, your rods are done. Your shield'll just blow up.
Yeah.
So anyways, but that's enough about that. But yeah, that's the thought behind it. All right, so I'm just finishing up on the LS build. A couple minutes ago, I just finished degreeing in the camshaft. Here's a shot of the setup. That's the degree wheel indicator, and I have my my dial indicator right here on the head. You know, these are a little bit more tricky because nothing on it is steel, so my magnetic base indicator doesn't stick to anything. So I had to make a plate, or not make a plate, but bolt a plate to it, then bolt an indicator to it. So that's the setup. So what's left is the front cover. Did I say with intake and center line? Well, it was at 110.5 degree intake center line was the measurement. So now it's just basically installing the front cover, bolting on the intake, priming the block, and you'll see in a minute, and bolting down the rockers. These springs are pretty mean, so I'll have to rotate the engine and wait until both cams are on bottom dead center, or not cams, both lobes are on the base circle, and then run the bolts down because I don't want to put a side load on these small 8mm bolts. And then after that, I'm done. So I'll just, the customer's supposed to be here today, pick it up, and then we're finished. All right, it's come time to pressurize the oil system on the LS. I had to rig up this this pressurized Sure Shot container that I use for just oil delivery on like machining or parts, whatever. So it just consists of a quick connect fitting and then a plastic line that goes to the block. I modified the port on the plug for the oil pump. So it's just I'm gonna pressurize it and basically lift the lifters, and hopefully it'll go through the push rods and the cam bearings, so that when he fires it up, it'll already be primed, ready to go. So now I'll put 120 psi in it and basically let it circulate. Okay, I'll have you rotate the motor while I pressurize the system, the oil galleys. But I have to have you have to put your hand over this and plug it. It'll press up.
It'll square at the top. I didn't know that initially. So push your finger over that and kind of videotape this, the lifters. I'm gonna rotate the motor to lift up the rockers. And I'm gonna rotate the motor over while I pressurize it. So I got about 100 pounds on it. So you'll have to leave your hand on it even after I finish, because there's
it'll still be,
yeah. So ready?
Yeah.
Oops.
Trying to rotate the crank?
Yeah.
Let's see. Coming through the push rods?
Yeah. Should be prime. I'll try and rotate it at the same time, but I don't think I can. It's funny, everything rotates easier when there's oil pressure.
Oh, really?
Yeah.
Oh.
So yeah, this motor is primed. So basically, I got oil coming out of the pump everywhere, basically. Push rods, lifters. So maybe it won't clack too much when he fires it up. But yeah, so that part's finished. So now I just need to put the intake on, valve covers, front cover, and this bad boy's done. So I think the best thing to do is right here, underneath the head, right there, and then the back of this here, the bar. Yeah.
You guys don't want to push it closer?
1, 2, 3.
not coming out. Oh, there you go. Come on, Andrew, you got it. No, they're gonna need help.
One, two, three. There you go.
Woo! Guys, to come over a little more. I gotta lift it. Hold on, hold on, hold on.
There you go.
Will it hold?
I think it might. Okay. We can pick it up again if you want.
Nope.